Hello, and welcome to 5 Minute Math. Today we are looking at the 8th grade concept of scientific notation. This is standard 8.3c in the great state of Texas, and we are using item number 24 off the 2025 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it. We will look at our answers together. All right, so we've got the sun, which can reach a temperature as high as 27 million degrees, which they give it to us in the unit form, and then they also give it to us in standard form. We need to write it in scientific notation. Now, you see a lot of 27s and 2.7s. We need to know what that means, and there is nothing on our reference materials that tells us what it means. So we have to come into our test knowing that scientific notation is two parts. It's going to be something times 10 to the something. Let's talk about this first something. So this is going to be a digit or a decimal, and it needs to be between two values, okay? So it needs to be less than 10, so up to 9.9 something, but it needs to also be greater than 1, so 1 point something. So between 1 point something and 10 point something. So it's manageable. And then this is going to be our exponent, right? So it's going to be positive if it's going to be greater than 0, and it's going to be negative if it's less than 1. So if it's a decimal, right? So a really large number like 27 million is going to have this right here. It's going to have a positive exponent there. Sometimes you might get a really small number like 0.00000079 or something. That's where the scientific notation becomes helpful, because when you have that many zeros, you kind of lose them, and it's kind of hard to say the number out loud or to work with it because there's just simply too many zeros. And so scientific notation is very helpful when we're dealing with very large or very small numbers. All right, so let's take what they gave us, 27 million. And so first, what do we need to do? We need to turn this into this first part, and let's just take our non-zero digit, so 2 and a 7. Let's turn that into a decimal that is between 1 and 10. So you see here, if we put a decimal right there, 2.7, that's going to satisfy the first part. Now, some of us might want to keep the 27 together, but you notice we've got two options here, A and B, that use 27. They are both incorrect, simply because it has to have a leading decimal between 1 and 10, not 27. 27 is still manageable, but it's still too large. It has to be less than 10. Second part is the zeros. Now, if we're just counting zeros, how many zeros are we going to get? 1, 2, 3, 4, 5, 6. Okay. But we need to think, if we multiply this by how many tens, how are we going to get that 2.7 to go back to 27 million, right? Every time we multiply by 10, we shift the decimal place once to the right. Okay, so 1, 2, 3, 4, 5, 6, 7. So it's not simply times 6 because there's 6 zeros. 6 zeros gets me this right here, but it doesn't get me to 2.7 to 27. So we need to include that seventh jump. Now, you don't have to take my word for it. We can actually use our calculator here. We can verify. So 2.7 times. Now, if you look next to the 7 over to the left, you see it says log, but if we click the blue second function, we're going to get 10 to the x. So it is good for our scientific notation. And then we're going to hit the 7, hit enter. Now it's going to give us without any commas, so we need to count our zeros. But it's 27 and then 1, 2, 3, 4, 5, 6 zeros, which is what we had. 27 and then 6 zeros. So that's how we can verify if you want to use the calculator. And you see here that even though this is technically correct, 27 times 10 to the 6th would get you, here's your 27 and here's your 6 zeros. It's incorrect because that 27 is not between 1 and 10. So our answer is C.